Scientists have developed a new method to destroy cancer cells using vibrating molecules, achieving a 99% success rate in lab tests. The research involves stimulating aminocyanine molecules with near-infrared light. This causes the molecules to vibrate in sync, effectively breaking apart cancer cell membranes. Aminocyanine molecules are typically used in low doses as dyes for cancer detection because they are stable in water and easily attached to cells. This new approach, referred to as molecular jackhammers, is a significant improvement over previous methods like Feringa-type motors, as it operates over 1,000,000 times faster and can penetrate deeper into the body using near-infrared light. This technology could potentially treat cancers in bones and organs without invasive surgery. The technique was tested on lab-grown cancer cells and mice with melanoma tumors, where half of the treated mice became cancer-free. The unique structure of aminocyanine molecules allows them to stay synchronized with the right stimulus, creating plasmons, vibrating entities within the molecule, that generate the mechanical force needed to tear cancer cells apart. This is the first time molecular plasmons have been used to achieve such mechanical action. The researchers are now exploring other molecules that could work similarly. This approach could provide a straightforward and effective cancer treatment that cancer cells would struggle to resist. Although still in its early stages, the findings offer promising new avenues for cancer therapy.
A new treatment for brain cancer has shown promising results, shrinking tumors by 50% in just 6 weeks. This offers hope for patients with glioblastoma, an aggressive form of cancer that is typically fatal within 18 months. One promising clinical trial involves injecting a small amount of radiation directly into the tumor. This targeted approach aims to kill cancer cells while leaving healthy tissues unharmed, potentially even eradicating the disease completely. Paul Red, a UK engineer, is the first patient enrolled in this trial. He has already seen his tumor shrink by half in a matter of 6 weeks with minimal side effects. Doctors are optimistic about this treatment method, especially since glioblastoma occurs in a single location and doesn't metastasize throughout the body. They plan to increase the radiation dose throughout the trial and eventually combine it with immunotherapy, which harnesses the body's immune system to fight cancer. In another exciting development, a new type of scan called immuno-PET imaging is showing promise in diagnosing and monitoring glioblastoma. This scan measures the levels of a protein called PDL1, which is found in high levels in rapidly progressing tumors. PDL1 acts as a brake on the immune system, and blocking it could help the body fight the cancer more effectively. A clinical trial of this scan involves a radiotracer that binds to PDL1, allowing doctors to measure its levels in patients. Early results are encouraging, with 3 out of 5 patients showing tumor stabilization after receiving pembrolizumab, a treatment that blocks PDL1. This new scan could revolutionize treatment for glioblastoma by providing a more personalized approach.
Scientists found a way to make cancer cells die from stress. The exciting new discovery helped get rid of aggressive brain tumor cells in mice. These tumors, called glioblastomas, are common and life-threatening. Their treatment, which hasn't changed much since early 2000s, involves chemotherapy, radiotherapy, and surgery. People with glioblastomas usually only survive for about 15 months after being diagnosed. But how did scientists get rid of these aggressive tumors? Cancer cells are naturally stressed, and they use this stress to their advantage. In the case of glioblastoma, they use a protein called IRE1 to become even resistant to cancer drugs and chemotherapy, and to migrate to new places in the body. The researchers wanted to weaken the cancer cells by messing with this process. They used computer models to find a molecule called Z4P that not only made the cells less resistant to treatment, but also stopped them from spreading. When they tested this molecule along with chemotherapy on mice, it made the cancer cells weaker, shrunk the tumors, and prevented them from coming back for 200 days. The molecule needs further modification for increased effectiveness against cancer cells and testing on more animals before human trials can be conducted.